Okay, so just like when we were doing lines, we tested points to determine whether or not that point is on the line. What we're testing here is not if it's on the line, because we don't want it on the line. We want to test to see if it makes a true statement. So what do you do? Plug it in, correct.
For the variables.
Go ahead, Isaac.
Alright, -2 times -1. Plus 5 times 2 is greater than or equal to 5.
Okay, so -2 times -1.
Oh, -2.
2, because negative plus up to positive.
She's right. 5 times 2
10.
is 12 greater than or equal to 5.
Yeah.
Bingo.
It's not equal.
Bingo.
Doesn't have to be. It's got to be
It says
greater than or equal.
to.
Oh.
0 minus 2 times 0 is greater than 4. 0 minus 0 is 0. Is 0 greater than 4?
No.
No. False. That's a skill you have to be able to perform.
Wait, why is that wrong? Number 2?
Because 0 is not greater than 4.
Oh, because, okay. got it.
Yep. We good? This tells you how to graph it. So you can keep that for reference, but I'm just going to show you how to do it because it's a little bit easier. So let's scroll up a little bit. I don't know why that's doing that. Stop that. All right, here we go. Graphing inequalities. All you need to do is graph the line first. So instead of an inequality, consider it a line. What can you tell me about that line?
The y-intercept is 5.
Good. 1, 2, 3, 4, 5. And
The slope is. Do you go down to that over?
down 2 over 1. Okay, now before I draw the line, you got to be aware of something. If this is a greater than or less than, you use a dashed line. If this is a greater than or equal to or a less than or equal to, you use a solid line. So for those of you who are visual learners, this or this, you use a dashed line. This or this, solid line. Which one are we using here? Dotted. There's no equal to under there. So using your straight edge,
That's a bad one.
because if we take any point on that line, it's not going to work. Because that would be an equation, and we don't have an equation, we have an inequality. Now, here's the easy part. Pick a point. Anywhere on the graph that's not on the line. What's a smart point to choose?
0.
How about 0, 0?
Yes.
Plug 0, 0 into the inequality. Is it a true statement? Is 0 greater than -2 times 0 plus 5?
No.
No, it's false. So the side that we picked on, which is 0, 0, is false, so we shade the other direction.
What do you mean by shooting? Like,
Color it
I
in.
remember doing this.
Cool.
I don't.
Oh, so,
I've never done it.
So wait.
Well, now you're learning. Go ahead.
so you plugged in 0 for the variables,
Oh, okay.
Correct.
I get it.
and then, wait, those
0 in for x, 0 in for y. Check to see if it's a true statement like we did in problems 1 and 2. If it's a true statement, then the side of the line that the point you picked is on, you shade towards that way. Just like we were doing a regular number line. So let's suppose I pick the point 1, 2, 3, 4, 1, 2, 3, 4. 4, 4 is over here. 1, 2, 3, 4, 1, 2, 3, 4. If I test that, I get 4 is greater than -2 times 4 plus 5, which is 4 is greater than -3. That's a true statement, so I shade towards that point. So it doesn't really matter what point you choose. However, 0, 0 is usually pretty easy. Okay? So again, graph it as if it were a regular line. In problem number 2, we have a line in standard form. How do we graph in standard form?
Simplify.
You could. Too much work. T-chart it up. If x is 0, what's y? Geneva.
What?
If x is 0, what's y?
2.
If x is 0, what's y? -2. Beautiful. Staying with you, Geneva. If y is 0, what's x?
4.
Beautiful. 0, negative 2. 4, 0. 1, 2, 3, 4. Solid line or dashed line? Solid, because we've got an equal there. Geneva, what point do you want to try? One, 1? Awesome. Plug in 1, 1 here. 3 times 1 is 3. 6 times 1 is 6. 3 minus, 6 is greater than or equal to 12. 3 minus 6 is negative 3. Is negative 3 less than or equal to 12?
Yes.
That's true. The number she picked is over here, so therefore we shade on that side of the line. You will, yeah.
Can you always pick 0?
Not always. The only time you can't is if the line passes through 0, 0.
Okay.
But most of the time I pick 0, 0 because it's usually not on the line and it's easy to plug and chug. Okay, question so far. Graph it as if it were a regular equal line. Determine if it's solid or dashed. Test a point. Shade. Done. All right, turn it over. Okay, now we've got this weird line. Negative 3y equals 5x. How do you want to graph that? Yeah.
Would there be a dot, a 0? Because there's no y-intercept.
There's no what?
Y-intercept?
Correct. So what is the y? There is a y-intercept. What is it?
0.
0. So we know it's going to pass through this point. Question is, what's the slope?
5 up and 1 to the right.
5 up and not 1, because you got a 3 there.
Oh. 3 to the left? Or
3 to
wait,
your left or my left? This way? Towards the windows or towards the door?
this way? I mean
Towards the windows.
Yeah.
Correct. So what I would do is solve this for y. Y is equal to, whoops, not equal. Get rid of that. Y is equal to 5 divided by negative 3x. Because again, we're graphing it as if it were a line, and then we'll test it later. So that tells you your slope. By the way, what's this called when you don't have a y-intercept, or when the y-intercept is 0? What did we call that? Ooh, tough one. What kind of equation is that when it doesn't, when the y-intercept is 0? Nope. Let's go. Bonus direct variation, very nice. Up 5, 1, 2, 3, 4, 5 over negative 3, 1, 2, 3. Solid line or dashed line? Dashed. Don't forget arrowheads. Now, strangely enough, Amanda, notice what's going on here? I'm passing through 0, 0, so therefore I can't use 0, 0. What point would you like to use? 2, 2. Beautiful. Negative 3 times 2 is negative 6. And we're wondering if negative 6 is greater than 10. Is it? Nope. So 2, 2, which is over here, is false. So we shade the other side. All right, do number 4 on your own. Question, Jordan?
Why would it be y equals?
Because you got to graph the line first. It's just like graphing an equal sign.
Okay.
Or graphing an equation,
And
I
then
should
how
say.
did you get 6 and 10?
Because she chose the point 2, 2. We tested 2, 2.
Oh, so you plugged
Plug
it
and
in.
chug. Yep. Notice there's no x there. Don't magically make an x appear. There is no x in this equation. If there's no x in the equation, what does the line look like? Horizontal. Correct. So solve for y here. Y is equal to -4. Because we have to graph the line first, and we'll go back to the original inequality and test it. What's the line y equals -4 look like?
Where do you get -4?
Subtracted 6 from both sides. 2 minus 6.
You should get line.
Oh.
1, 2, 3, 4. Solid dot, dashed line or solid line? Dashed. Uh-oh, pen not working. There, no. Come on. That's supposed to be dashed. Okay. What point you want to test? I would test 0, 0 on this one. Is 0, well, if I plug 0 in there, I get 0 plus 6 is 6. Is 6 less than 2? No, so we shade the other side, which is all of this stuff down here. And then notice in number 5, what's going to happen in number 5? There's no y term. What's that line going to look like? Vertical. Solid line or dashed line? Solid. Test a point, shade. Go ahead and give that a shot, see what it looks like. How'd you start in this problem? Divide by -3. And when you divide by a negative number, what do you got to do to the sign? Yeah, so x is greater than or equal to -3. So graph the line as if it were an equal sign. So that's a vertical line through -3. 1, 2, 3. Put a dot there. Solid or dashed? Solid. What point do you want to test?
-1.
-1. Just -1 isn't a point.
-1, comma 0.
-1. Why do you want to make your life so difficult? Pick something easy.
0, 0.
0, 0 is pretty easy. How about 5, 5? 4 million, 4 million.
Yeah.
You can test whatever you want. But pick something easy. Let's put 0 in there. 0, 0. Is 0 greater than or equal to -3? Yes, it is. So therefore we shade towards the point we tested. Okay, so I outlined all the steps for you there. There are 3 steps. Graph the line, like we've done already. Turn the inequality into an equal sign. Graph the line like we learned last chapter. Step 2, decide before you actually draw the line, decide if you have a dashed line or a solid line. Draw the line in, and then pick a point on one side or the other of the point of the line. It doesn't matter what point you pick, as long as the point's not on the line. But again, make your life easy. Pick something nice and simple. 0, 0, 1, 1, -1, -1, something like that. Plug and chug and test if it's true. So A and B are your two possibilities. If that point works, if it gets you a true statement, shade towards the point you tested. So we tested 0, 0 on this problem, and 0, 0 works, so I shaded on that side of the line. If the point doesn't work, gives you a false statement, then shade the other side away from it. Okay. Yeah.
I just don't understand how you find the points for the line.
You've got a couple different options. You can use slope-intercept. You can use standard form. That's all the line graphing stuff we did last chapter. Is that what you're asking, how to get the line itself? Yeah, take the inequality and write it as an equality and graph the line. So if I give you something like y is greater than or equal to 2x minus 4, how are you going to graph that? Well, turn into an equal sign. And now figure out how you're going to graph that. How do I graph that line?
Divide by 2.
Nope. What's the y-intercept?
Oh, 4.
Negative 4. What's the slope?
2.
Up 2 over 1. Straight line or dashed line? I'm sorry, solid line or dashed line? Solid, because it's an underline there. And then pick a point to test. Test it. If it works, great. Shade towards it. If not, shade the other way. Okey doke. Beautiful. Let's stop this. Then I got some homework for you. And then we will be